The sticky bead argument is a thought experiment developed by physicist Richard Feynman in the 1950s to demonstrate the physical reality of gravitational waves. At the time, there was a debate among physicists about whether these waves, predicted by Einstein's theory of general relativity, were real phenomena that carried energy, or just mathematical artifacts of the equations. Feynman's simple and intuitive argument helped settle the matter. The setup. Imagine a long, rigid rod placed in a vacuum, far from any other gravitational influences. On this rod are two small beads, which are free to slide along its length. The beads in the rod are not rigidly fixed to each other, but they have a tiny amount of friction between them. The argument: 1. A gravitational wave arrives. A gravitational wave is essentially a ripple in the fabric of space-time, causing a temporary stretching and squeezing. As this wave passes by our setup, it will try to change the distance between the two beads. 2. The rod resists. The rod itself is a solid object, and the electromagnetic forces holding its atoms together are immensely strong, far stronger than the tiny tidal forces from a gravitational wave. Therefore, the rod's length remains fixed. 3. The beads move. The gravitational wave causes the proper distance between the beads to oscillate. However, because the rod's length is fixed, the beads are forced to slide back and forth along the rod in response to the wave's oscillations. 4. Friction generates heat. As the beads slide along the rod, the small amount of friction between them generates heat. This heat is a form of energy. 5. Energy conservation. According to the law of conservation of energy, this new energy in the form of heat must have come from somewhere. The only possible source is the passing gravitational wave itself. Conclusion: Feynman's argument showed that a gravitational wave can do work on a physical system, the beads and rod, transferring energy to it and causing a measurable, irreversible effect, the increase in temperature. Because it carries energy and can do work, a gravitational wave is not just a mathematical curiosity. It is a real, physical phenomenon. The sticky bead argument was a powerful tool for conceptualizing gravitational waves and helped pave the way for the development of detectors like LIGO, which finally confirmed their existence in 2015, over half a century after Feynman's famous thought experiment.